Good day, math wizards! Welcome to our subject, Modern Geometry. Stay still and open your minds because today we begin our journey into the shapes, spaces, and ideas that build our world. So our first topic is all about planes, lines, and separation. But before that, let's define what is geometry. So geometry is a branch of mathematics that studies shapes and figures. So whether they lie on a flat surface like notebook or exist in space like a basketball or a pyramid. So the word geometry comes from two Greek words. Geo means earth and metron means measure. So geometry simply means measuring the world and everything in it. So before we dive deeper, so let's start with the foundation or the building blocks of geometry. So these are called undefined terms. So why they are called undefined terms? So that means we don't define them using other shapes or words. So just like in art, we don't define what this color is. Or in music, we don't explain what a note is. We just use them to build more complex ideas. So in geometry, we have three undefined terms. So these are point, line, and plane. So let's begin with a point. So point is the simplest figure in geometry. So it's just a location. So it has no dimension. So it means it has no length, no width, no height. It means it has no size. Imagine what a point is. It has no size. So can you imagine? So we can represent point by a dot. So use dot to represent a point. We use capital letters to name it. For example, you have point A. So you just wrote a dot in big letter A. That is how to name a point. So, example representation of point, we have a grain of sand, a star in the sky, the tip of a ball pen, and many more. So even though it has no size, every geometric figure is made up of points. So next, let's talk about line. A line is a straight path of points that extends endlessly in both directions. It has one dimension. So it means a line only have a length, but it doesn't have a width or thickness. So all it takes is 2 points to determine a line. That is, through any 2 points, there is exactly one line. So in order to name a line, we just need to use lowercase letter or any 2 points on it. So for example, line F or line AB. So, example of line, we have the edge of a table, the crease when you fold a piece of paper, a ray or beam from a laser, and many more. Now imagine a plane. So, what is a plane? So, a plane is a flat surface that extends forever in all directions. So, it has length and width but no thickness. So it means a plane is two-dimensional. It only has length and width but no thickness. What do you call those with thickness? Three-dimensional. Have length, width, and thickness. So they are called a space. So example representation for plane, we have the top of a table, a wall, a chalkboard, and many more. So we name a plane using either a lowercase letter or 3 points that lie on it, since a plane can be made through any 3 non-collinear points. Now, let's talk about the fundamental relationships. So first, we have collinear points. So collinear points are points that lie on the same plane. So for example, if points A, B, and C all lie on line M, then they are collinear. So it means that points that lie on the same line are called collinear points. Next is coplanar points. So these are points that lie on the same plane. So for example, points A, B, C, and D all lie on flat surface on top of your table. So it means they are coplanar. Since points A, B, and C lie on the same plane. So points that lie on the same plane, they are coplanar, and points that lie on the same line, they are collinear. Next relationship we have is intersection of lines and planes. So two lines intersect at exactly one point. When two planes intersect, then their intersection is a line. Next is parallel and perpendicular. So when you say parallel lines, they are lines that never met. Never met since they have the same slope or steepness. Next is perpendicular lines. So when you say perpendicular lines, these are lines that intersect and form exactly 90 degrees. Now, let's move on to line postulate. So what do you mean by line postulate? So this states that through any two distinct points, there is exactly one line. So you just need two distinct points in order to form a line. Then, however, plane postulate states that through any three non-collinear points, there is exactly one plane. So in order for you to form a plane, you just need three non-collinear points. Next is space postulate. So space contains at least 4 points, not all in the same plane. So for you to make a space, so you need 4 points not in the same plane in order for you to create a space. Now let's move on to convex sets and separation. So what is convex set? So convex set is a set of elements from a vector space such that all the points on the straight line that lie between any 2 points of the sets. So it's a special kind of group of points. So if you pick any 2 points in the set, the entire straight line segment between them must also lie completely within the set. So for example, think of a solid circle or triangle. If you draw a line between any 2 points, inside them, that line stays completely inside. So if you connect the 2 points to choose that set, if they line that it forms lie inside, completely inside, then it is a convex set. However, a crescent shape or a donut, so is it convex or non-convex? So of course not, because the line might fall outside the shape or through any empty space. So that is a non-convex set. So what is plane separation postulate? So plane separation postulate states that a line drawn in a plane divides that plane into 2 distinct, non-overlapping convex regions. So these regions are called half planes. So this postulate also known as the Sachs postulates. So the moment you draw a line, you create 2 separate sides of the plane. So let's break it down. So first we have the disjoint set. So disjoint set is the 2 half planes that do not touch or overlap. So they are disjoint, means they are completely separate and distinct. So imagine slicing a piece of paper with a line. So you now have a left side and a right side. They don't mix. Next is convexity. So each of those half planes is convex. So if you pick any 2 points on the same side of the line and draw a segment between them, then that segment stays completely on that side. That's why you can say it is convex. Next, now what happens if you pick 1 point on each side of the line? Then the segment connecting them will always cross the line. So there's no way to go from one side to the other without passing through the line that separates them. So think of this like trying to walk from one side of the fence to the other. So you'll have to cross the fence line at some point.
Good day everyone, let me take you on a journey not just through a city but through history, curiosity, and the beginnings of the new way of thinking. So first, our story begins in the city of Königsberg, an old city in East Prussia which is known in Kaliningrad, located in modern-day Russia. So back in the 18th century, Königsberg was known for its beauty, its intellectual spirit, and most famously, its 7 bridges. The Prigel River flowed through the city, dividing it into 4 separate land areas. 2 of these were islands in the middle of the river, and the other 2 were the river banks on either side. To make the travel between these areas easier, 7 bridges were constructed to connect the lands. These bridges made the city even more interesting both in design and in daily life. But then something curious happened. The people of Königsberg created a puzzle, a challenge that fascinated not only locals but also scholars and thinkers. The puzzle was this. Is it possible to take a walk through the city and cross each of the 7 bridges exactly once without crossing the same bridge twice and without skipping any bridge? At first, it seems like something fun, a little brain teaser, but the more people tried, the more they failed. And soon, it became more than just a puzzle, it became a mystery. Now, let me introduce you to the 7 bridges of Königsberg, each with its own unique place in this puzzle. The first bridge is the Merchant Bridge, the Blacksmith, the Green Bridge, the Dawn Bridge, the Honey Bridge, the High Bridge, and the Wooden Bridge. Today I will discuss about Leonhard Euler. So, Leonhard Euler, he was born on April 15, 1707 and died on September 18, 1783. He was a Swiss mathematician, physicist, astronomer, geographer, logician, and engineer. So he made significant contribution to many branches of mathematics. So Euler discovered and popularized the use of the following symbols. The first one is the Greek letter pi, which is the Archimedes' constant ratio of the circumference of a circle to its diameter. Second one is the term f of x, which is used to describe the y-axis function. The next one is the letter I, which is used to express imaginary unit equivalent of the square root of -1. The fourth one is the Greek letter summation, which is used to represent summations. And the last one is the letter E, which is the new mathematical constant known as the Euler's number representing a natural base in logarithms. It is approximately equivalent to 2.71828. Next, we have Euler also discovered the formula relating to the number of vertices, edges, and faces of a convex polyhedron. And he is also known to have proposed a solution to the problem on the 7 bridges of Königsberg. The question is
is there a possibility of the following path that crosses each of the following bridges once returning to the starting point? In the year 1735, he represents the solution to the problem using a graph theory. His solution was thought as one of the first theorems in graph theory. Next, Euler's contributions have had a lasting impact on mathematics and science. His work continues to influence various fields, including mathematics, physics, and engineering. So that was all about Euler's, and thank you.